Beneath an ordinary public park in Singapore is enough drinking water to fill 3 Olympic swimming pools. Under the city is a tank designed to swallow a sudden tropical storm. And far below Jurong Island are caverns large enough to hold millions of barrels of fuel. Singapore's next expansion is not only going up or out, it is going down. But this is not a secret city of underground homes. It is something more practical, a hidden layer of infrastructure that keeps the city above working. Singapore has about 736 square kilometers of land and more than 6 million people. Every new road, utility plant or storage site competes with housing, industry and green space. Reclamation can create more land, but it is expensive and cannot solve every constraint. Tall buildings help, but essential systems still need somewhere to go, so planners are treating depth as a new dimension. Draft Master Plan 2025 materials say Singapore already has about 300 kilometers of underground tunnels, with roughly 60 kilometers more planned over the next decade. The goal is not to bury everything. It is to move the right infrastructure out of the way of daily life. The clearest example lies beneath Jurong Island. About 150 meters underground, the Jurong Rock Caverns form Southeast Asia's first commercial underground liquid hydrocarbon storage facility. 5 caverns contain 9 storage galleries carved into solid rock. Some are roughly 9 stories tall. Together, they can hold about 1.47 million cubic meters of product, roughly 9 million barrels. The important number, however, is on the surface. Placing this storage below ground frees around 60 hectares above land that can support other industrial uses on an island where every parcel matters. The rock itself becomes part of the structure, but this is not simply an empty hole. The facility still needs access tunnels, pumps, ventilation, monitoring, and layers of engineering to keep it safe. The largest underground story may be one most people never see: the Deep Tunnel Sewerage System. Instead of relying on many scattered treatment sites, used water flows through deep tunnels toward major water reclamation plants. Gravity does much of the work, reducing the need for intermediate pumping stations. Across both phases, the network extends about 206 kilometers. Costs roughly 10 billion Singapore dollars, and is designed to serve the country for a century. Phase 2's tunneling finished in 2023, but that does not mean the whole expansion is already operating. Commissioning is planned progressively from 2027. Once complete, PUB says the system could cut the land occupied by used water infrastructure by about half and free up to 150 hectares. It also carries a resource Singapore cannot afford to waste. The water is treated, purified, and returned as new water, closing part of the national water loop. What makes the underground strategy remarkable is how normal the surface can look. At Bidadari Park, families walk above a service reservoir holding about 3 Olympic pools of drinking water. By placing the tanks underground, PUB saved around 1,500 square meters of surface land without moving the water supply away from the neighborhood it serves. Near Orchard Road, the hidden job is different. During intense rain, water can be diverted into the Stamford Detention Tank, 28 meters below ground. It holds up to 38,000 cubic meters, then releases the water after the storm has passed. At Labrador, SP Group placed a major electrical substation underground and built a 34-story commercial tower above it. These projects solve different problems, but they follow the same idea. the ground no longer has to perform only one job. A park can also store water. A commercial site can also distribute electricity. A busy district can hide part of its flood defense beneath the street. Singapore is now studying what the next layer could contain. One possibility is storing construction aggregate in a cavern near Gali Batu, freeing valuable surface space while keeping material close to the city. Planners are also examining underground stormwater systems and whether battery storage can operate safely below ground. Further ahead, automated logistics could move selected goods below the streets, reducing some surface traffic. But these are possibilities, not promises. A feasibility study is not an approved project, and a concept drawing is not a construction site. Each idea has to justify its cost, safety, and location before it earns a place beneath Singapore. Underground space is not free space. Excavation can cost far more than building on the surface. Singapore's geology changes from hard rock to softer ground, so a design that works in one area may be unsuitable in another. Waterproofing must last for decades. Ventilation, fire protection, and emergency routes have to work when the nearest open air may be far above. Construction must also avoid damaging roads, buildings, and utilities at the surface. And some systems still consume energy to pump water, circulate air, or move people and equipment. Building underground is valuable only when the surface land it releases, or the resilience it creates, is worth the added complexity. Singapore is not building a second city beneath the first. It is building the systems that allow the visible city to remain livable. That may be the real future of dense cities, not choosing between a park, a water tank, and a power station, but learning how the same piece of land can support more than one purpose. If Singapore could move one more thing underground, what do you think it should be? Tell us in the comments. So there you have it. That's what it turns out to be. If this answered a question you didn't know you had, hit subscribe so you don't miss the next one. And if you liked it, tap that like button. Turns out, it actually helps a lot.